is on controlled blasting. The team members include Derek McElveen, Cole Fuller, and Ross Gray. The topics that will be discussed throughout this presentation include intro, executive summary, motivation, NHN, info, biomass, benefit analysis, and conclusion summary. Whenever a job site calls for the removal of large quantities of rock, the most often preferred method is through blasting. Blasting is far more productive in removing rock than any mechanical means. Blasting is believed to have started in 1627 at the Royal Mines in Hungary. It began when miners got the idea to pour black powder into a hole drilled into rock. The black powder was then lit, causing an explosion, and the rock fragments went everywhere. From that point on, blasting has progressed to more productive and safer methods. As mentioned before, black powder was the first explosive used in blasting. As technology slowly progressed, black powder was eventually replaced with a new explosive, nitroglycerin. In today's blasting methods, we are using explosives such as ANFO, ammonium nitrate and fuel oil, and NHN, nickel hydrazine nitrate. There are three main drives behind blasting in today's construction industry. The three motivations include safety, cost, and production. As with any construction project, safety is the number one concern for any task being done. These methods today are far safer than those of the past. As technology has progressed, blasting has gotten cheaper by the use of more advanced explosives that cost less than previously used explosives. Along with this technology, the explosives have become more effective and better placed throughout the intended blast site. The reason this industry is where it is today is due to the research from case studies to gain better knowledge on the equipment and rock fragmentation. There are four main techniques used in controlled blasting today. These techniques include line drilling, smooth blasting, cushion blasting, and pre-splitting.
With the number one priority in the industry today being safety, nickel hydrazine nitrate, also known as NHN, brings a lot to the table. It is 30% less sensitive to friction, making it much safer to handle in all phases, manufacturing and in the field. The liquor used to create NHN may be recycled and used again and again. Therefore, harmful wastewater pollution is not produced during the manufacture process. NHN has been experimented with as a replacement for lead azide, also known as ASA, as the primary explosive used in detonators. As you can see in the two tables, the experiment results yield very similar values for both NHN and lead azide, indicating that the blast performance of NHN is the same as that of lead azide. ANFO is the most widely used explosive in the construction and mining industry, as it currently is 80% of explosives used annually. The development of mixing biomass with ammonium nitrate has developed an average cost savings of 11% for the mixture, as you can see on the table. Biomass briquettes of white coal is substituted in the formula for a quantity of ammonium nitrate, normally about 6 to 8% of the entire formulation. Whereas a standard formula, ANFO, would consist of 1,000 kilograms of ammonium nitrate and 70 liters of diesel. The formula with biomass has 910 kilograms of ammonium nitrate, 90 kilograms of biomass, and 40 liters of diesel. As you can see on the table, 90 kilograms of biomass replaces 90 kilograms of ammonium nitrate. The biomass that is used in this process can be anything from forest leaves, coffee husks, to maize stalks. These materials are so readily available that it allows the cost savings to be very large, considering it only makes up 8% of the materials in the formula. These biomass materials are crushed up and homogeneously mixed with the ammonium nitrate to produce the new ANFO formula. By using the biomass, less NOx and CO2 are produced as a byproduct from the explosion. This makes working out at the construction site safer for workers as they are not breathing in harmful gases.
Controlled blasting methods vary in order to control adverse impacts, reduce ground vibrations, and reduce fractures within rock walls. Some controlled blasting techniques are line drilling, trim blasting, smooth blasting, pre-splitting, and muffle blasting at critical and congested areas. Ammonium nitrate and diesel fuel and other modern explosives are used to improve safety and effectiveness in blasting. ANFO has found wide use in coal mining, quarrying, and civil construction due to the advantages of ANFO's low cost and ease of use. An emulsion is a mixture of two or more liquids that are normally unblendable. Emulsions are a part of a general class of system where one liquid is dispersed into the other. The explosive use varies from each job site depending on the soil characteristics, as well as the geological conditions. Detonators are defined most commonly as cylindrical metal shells closed at one end and are ignited by a blasting fuse or an electric igniter. This report represents the data collection, analysis, and productivity improvement of controlled blasting techniques. Concerns over safety, money, and time have led to many of these changes and resulted in products that are more efficient. NHN and ammonium nitrate fuel oil are the recent advancements in controlled blasting. In the future, technology advancements will likely be made to blasting networks in order to decrease the risk of harm to those working in and around the blast site. Safety is vital to the overall goal throughout any construction activity, and this method not only meets the safety requirements but contains costs while increasing production. Throughout our report, many key explanations have been identified that will continue to drive the productivity of controlled blasting throughout our future.